Alright, so when we talk about domain and range, I know that domain is everything to the left and everything to the right. And we've talked about domain and range on number 2, so let's look at that one first. So when I talk about the domain on this one, the fact that it keeps going left, keeps going right, the domain is going to be all real numbers. Remember that we can actually write the words all real numbers, or we can write the symbol, the little fancy R thing, or you could write negative infinity to infinity, whichever way you prefer. Let's look at the domain on number 1 before we talk about the range. So on number 1, when we talk about the domain, we're talking about the graph again, going from the left to the right. And we want to know if there's any breaks in between it, or if it stops anywhere, or if it just keeps going forever. So this one went forever to the left and the right. This one does too. It just up and down is how it goes, and it goes forever. So for the domain on this one is also all real numbers. Again, you can write negative infinity to infinity, you can write the little fancy R, or you can write the words all real numbers. So both of them have the same domain, so that's interesting. So now let's talk about the range. The range has to do with going up and down, okay? And the question is, does it go up forever and down forever, or does it stop? So this one, again, the range is all real numbers because it keeps going. Anytime that you have a line, any line, the domain and the range will be all real numbers because it keeps going left and right and up and down. Okay. Now, absolute value graphs are very similar to parabolas, and we'll look at some of those in a minute. But this is what we've been talking about the range. Like, it keeps going up forever, but it stops. Okay? And when you talk about where it stops, when we're talking about the range, you always talk about the y value. And we've talked just a little bit, like, if you think about the y-axis, negative infinity's up here and infinity's up here, the graph keeps going up and it hits, I did that wrong, negative infinity's down there, positive's up there. Sorry, I wrote that wrong. So anyway, it keeps going up, so infinity will be in our answer, and it stops here at 0. 0 is my y value, so it's 0 to infinity. Infinity always has a parentheses, and then the other value, as long as it touches it, is included. Alright, number 3. Okay, let's think about the domain first by itself. So, talking about going left and going right. Okay? Well, looks like it keeps going this way. Keeps going right. But it doesn't keep going left, it stops. Okay? Again, think about negative infinity and infinity as being on the number line. It's going this way, so I know infinity will be included, and it stops here. So it looks like it's going to be 0 to infinity for the domain. For the range, I'm thinking about it going up and down. Okay? It goes up forever, goes down forever. So the range is all real numbers. So what I wanted you to realize on that one is just because the domain might be all real numbers a lot of times, that doesn't mean that it always is. Sometimes it's the range that's all real numbers. So both of these are similar to what we did earlier with the line and the parabola, or in the absolute value. So let's talk about number 6. Alright, number 6 is a little different because it doesn't keep going forever. It does keep going left and right on the ends, and it does keep going up and down on the ends, but it doesn't connect in the middle. Okay? In Math 2, you may or may not have seen a function like this. It's called a rational function. And there's this thing called an asymptote. And it's this value in the middle of it that it doesn't touch. So the graph gets really, really close to that dotted line, but it never touches it. Okay? So what that means for the domain, because it keeps going this way, and as I go towards it, it gets every single value except for that place right there in the middle. Okay, so what that means is it's all real except whatever that place is that it doesn't touch. So in this case, it's all real numbers except x equals 3. Anytime you have a function that looks kind of like that, it's called a rational, and the graph doesn't touch some value in the middle of it, it's everything except that value it doesn't touch. Okay? Now the same thing happens for the range. Because if you'll notice, it keeps going up forever, keeps going down forever, but it doesn't touch this value right here in the middle. Okay? Again, there's like this little dotted line in the middle of it. And you just sort of have to figure out where the middle of it is based on the graph. But in this case, that's 0. So again, the range is all real, just not including 0. Notice the domain always has x values and the range always has y values. Let's look at these down here. So we've done one sort of like this. We've done one sort of like this. Let's look at number 8. Okay, and we'll come back to 7 and 9. So number 8, when I talk about the domain, you see how the arrow keeps going that way? So that means it keeps going to negative infinity, but then it stops. So as far as to the right, it stops here. And remember, you start on the left and then go to the right. So domain was going to be negative infinity to wherever it stops, which in this case is 4. Okay, let's look at the range. So for the range, it keeps going up forever. So it keeps going to infinity, but then it stops right here. That y value is 0. So the range is going to be 0 to infinity. If negative infinity is your answer, in your answer, negative infinity will come first. If infinity is in your answer, infinity will go last. And it's because you always do smallest to biggest. Smallest to biggest. Okay, you guys try number 7 and 9. So on the first one, I know it starts at 0 and keeps going to the right forever, so that would be 0 to infinity. As far as the range, it just keeps going up forever, keeps going down forever, and so that would be all real numbers, or our fancy R, however you want to write it. Let's look at number 9. For the domain, keeps going left and right forever, so domain's all real. But for the range, goes up forever, but it stops down here. And remember, you start bottom to top. So bottom is negative 5, and it keeps going up. So negative 5 to infinity with a bracket. Okay. Let's look at some of them on the back. We have so many choices to look at. Okay, so number 10. This graph is an actual trig graph, and we'll be looking at some of these graphs later on in the semester. Notice that it's called oscillating. It just keeps going back and forth and just keeps doing that the whole time. So as far as like the domain, just keeps going forever. Never stops. Nothing in the middle breaks it. So the domain's going to be all real numbers. The range is interesting on this one, because what you're trying to figure out is how far up it goes and how far down it goes. This graph doesn't go up or down. Okay? It stops. Basically, what's going on here is it's kind of in between these two red lines, always, because it never goes outside of it. It never goes above the two lines. So what that means for the range is that the range is those two values, just from that bottom to top. And if this is 0, that's negative 1 and 1, so the range is going to be negative 1 to 1. Now number 11 is similar, in that when you think about the domain and range, it doesn't go outside of the circle. It's always just in the middle of those values that's included. And actually that makes it a little bit easier maybe, because it's not outside of the values. What that means is for the domain, it's from here to here, which is -2 to 2. For the range, it's from here to here, except I start on the bottom, and that's -3 to 3. So you just do it in that range, and then that's it. We'll let you try 12, 13, and 14, but I'm going to do 15 with you. So 15 is another kind of function. It's called a polynomial function. It's another one we'll be looking at later on in the semester. And on this graph, as far as the domain is going, left and right, it does all this stuff here, but it's got these arrows. And the arrows just meaning that it's going left forever, it's going right forever. So the domain is all real numbers. All range. I mean all real. There we go. Alright, the range. I clearly see it's going up forever because I see those arrows. However, it stops right here. That's like the lowest it'll go. So it looks like that the range is going to be 0 to infinity. Alright, you guys try 12, 13, and 14. So on 12, we've got the domain is -3 to infinity, and then the range is all real numbers. On 13 and 14, again, it's just between those maximum and minimum values, and so here is the domain and range on those. Let's try the rest of these, and then we'll talk about them. So on 16, it's included just in the middle of everything, so from there to there and there to there. On 17, it does keep going right and left always. It does keep going up always, but it stops here at -3. So that's why for the range it's from -3 to infinity. On 18, if I think about left to right, it's -infinity to wherever this is, which is 2. And if I think about up and down, it goes up forever, so there'll be an infinity, but then it stops at -2. Because 21 has that open circle, that's why there's parentheses, and that's a case where there's a parentheses always, instead of a bracket, because we don't actually get to that value, because that open circle means it doesn't really touch it. So all the other times we have those brackets on the numbers if there's numbers included, but that would be a time where there's a parentheses. I didn't put a problem like this on there, but I want to show you one more just because it's kind of different. This is called an exponential function. This is another problem where there might be some parentheses. And so let me talk about it first. So the domain on this problem is all reals because it keeps going left and right. But the range is the one I wanted to talk about. So for the range, it keeps going up forever. But it doesn't keep going down forever because it kind of stops down here at the x-axis. It never goes past the x-axis. And so the range on this one would be 0 to infinity. And that would be another case where there would be a parenthesis and not a bracket because it doesn't ever get to that point.